The Pro Agent option package displays information on process diagnostics in uniform, standardized pictures on the appropriate display devices. They are already linked with each other via a predefined set of buttons. The message picture displays all the process diagnostics messages in the order of their occurrence. The overview displays all the diagnostics units with any subunits they may have. In the detail view, you get a display of the faulty network or the transition concerned. The display is derived from the result of the criteria analysis by marking the addresses classed as being faulty in statement list code or as ladder network. Via the motion pictures, you can visualize the state of a motion. Via direct buttons on the display device, you can go through each configured motion manually, for example after clearing a fault to get the system back to a defined state. If there is an S7 graph sequencer behind a faulty unit, then here you get a display of the steps there are and at which step the sequencer is at the moment. The sequencer can be initialized from here, or you can enable or disable a specific step. In the following, we want to demonstrate a few typical configuration sequences for process diagnostics. We have chosen a brief example for each language. In ladder, function block diagram or statement list, we will see address monitoring using S7-P-Diag add-on. In S7 Graph, we will configure a supervision and an interlock for a step. And in S7 High Graph, we will configure a monitoring time in a state. All the examples will be visualized with Pro Tool Pro and Pro Agent. Let us begin with the example of address monitoring with S7-P-Diag. We open FB20 in the block view of the Step 7 project. This contains a general run release signal that is linked via an individual logic distributed over several networks. In Network 4, we select the assignment Gen Release and activate the process monitoring dialog. Via the New button, we want to configure an address monitoring. In the next dialog, we parameterize the monitoring of a falling edge, enter a delay time of 1 second, and the message text. The formal parameters in the message mean that when there is a fault, the faulty unit and all the signals concerned are displayed in clear text. We acknowledge the dialogues and save the FB20. Then the monitored address will be marked in yellow. We close the block editor. In the block overview, we now see that the FB20 is marked as supporting diagnostics. Since the instance DB of the FB20, in our case DB20, also needs this attribute, we open this block in the statement list editor. In the Properties dialog, we go to the Attributes tab and give the S7-P-Diag property the value True. In the block overview, we see now that after saving the block, the DB20 has also been marked as supporting diagnostics. We now call the process diagnostics application S7-P-Diag. In the Explorer view in the left window, we see all the units of the program that support diagnostics. In the right window, you have a display of all the signals monitored and also the type of monitoring. Via the menu item Process Diagnostics, Compile Completely, we now generate all the monitoring blocks. In the block overview of the Simatic Manager, we see the newly generated monitoring blocks and the required system functions. Then we open the OB1 and insert the code lines for calling the monitoring blocks. We save OB1 and close the block editor. Now we load the Step 7 project into the CPU. We open the Pro Tool Pro project from the project view of the Simatic Manager. In order to be able to configure with Pro Agent, we go to the menu item System and open the dialog Pro Agent. In the Standard group, we select the unit that supports Diagnostics and transfer it to the Selected Units window. We close the dialog with OK, save the project, activate generation, and then start the run time. As soon as a process fault is triggered for which monitoring has been configured, a pop-up window opens containing the configured message text. We acknowledge the message and switch to the message picture and to the detail view, where we can determine not only the addresses that caused the fault, but also the associated controller, the unit, and the network in which the fault occurred. With the F8 button, we can have the signals in the statement list network displayed. With F7, we get not just the links which include the faulty addresses, but the complete network. Again, with F8, we switch to the ladder view. Here too, we can have both a section or the entire network shown. The following example deals with the configuration of interlock monitoring and supervision monitoring in the S7 Graph language. We open the block that contains the sequencer. A supervision means that a message is triggered when the step concerned is not completed within a certain time. Depending on the global settings, the active step is then closed. We select Step 4 and insert in the wildcard for a supervision a comparator as time monitor parameterized with a monitoring time of 5 seconds. Step 4 is now marked with a V. An interlock means that a message is triggered when the interlock conditions are no longer fulfilled, and all output actions linked with the interlock are blocked. To build an interlock into Step 5, we select the step and in the relevant wildcard we insert an AND operation which we assign to the safety guard closed address. Step 5 is marked with a C. We now link the interlock to the action drill lift. If the safety guard is opened while Step 5 is active, the command output is blocked. Now we have to make the following general settings for S7 Graph. We open the Block Settings dialog, and in the Messages tab, we activate Display Acknowledgement on the HMI device, both for interlock and for supervision. We acknowledge the dialog and then save the sequencer. load it into the CPU and close the editor. Now we open the Pro Tool application. In order to be able to configure with Pro Agent, we go to the menu item System and open the dialog Pro Agent. In the Standard group, we select the unit that supports Diagnostics and transfer it to the Selected Units window. We close the dialog with OK, save the project, activate generation, and then start the runtime. Once a process fault has been triggered, for which the supervision has been configured, in other words, the lower step was not completed within the time limit set, the supervision fault is announced in a message window. We acknowledge the message and switch to the overview in which we can see at which level and in which unit the fault has occurred. In the detail picture, you also get a display of the step, the transition, and the faulty address. Now, with the F8 button, we switch over to be able to see with which operation this address is linked. Another click on F8 shows us the address in the ladder view. With Shift F5, we switch to the sequencer view in which the number of the blocked step is marked red. After clearing the fault, we have to acknowledge the supervision fault. Only then is processing of the sequencer continued. If the safety guard is open during the lifting state, the interlock fault is announced. We acknowledge the fault and open the overview in which we can determine at which level and in which unit the fault has occurred. In the detail picture, we see the step concerned and the transition as well as the address that caused the fault. With the F8 button, we switch to the statement list and ladder views to see how the address is linked in the program. In the sequencer view, just as with the supervision fault, the number of the faulty step is marked in red. Once the fault has been cleared, the sequencer starts to process again automatically, unlike with the supervision fault. The following example shows the configuration of simple state monitoring in the S7 Graph language. In the Simatic Manager, we open the relevant state graph entitled Clamping Device. Here we want to time monitor state 2. For this, we only have to parameterize a maximum state dwell time with a monitoring time. We save and compile the state graph and load it into the CPU. Now we start the Pro Tool application. In order to be able to configure with Pro Agent, we go to the menu item System and open the dialog Pro Agent. In the Standard group, we select the unit that supports Diagnostics and transfer it to the Selected Units window. We close the dialog with OK, save the project, activate generation, and then start runtime. Once a process fault has been triggered for which there is monitoring, a window is opened in which the state fault is announced. We acknowledge the message and switch to Overview. There we can identify the faulty unit and by pressing the F1 button, the faulty subunit. Here the state graph clamping device. We change to Detail View to see the addresses that caused the fault, plus the level, unit, state and transition in which the fault occurred. With the F8 button, we can display the operations with which the addresses that caused the error are linked. If you click F8 again, you get the links displayed in ladder.